So we continue our lesson, the lesson that we started yesterday, and then after finishing this we will talk about the exam. So if you see the school stuff, I have to put the exam on week 12, unfortunately, because of this week which was not anticipated before it. So yeah, we will have the test on week 12. I have already updated the school soft. Okay, and then of course after the lesson ends, if you want to say something, I will be hearing you. Okay, so here, if you remember yesterday, we started talking about an equation for the straight line. So we got this, that an equation of a straight line is either of this form, x equal to a number, or of this form, y equals to a number, or we'll realize that we could write it as kx plus m, and we call this the k form, or if you remember, first we got this formula, y minus y naught is equal to k times x minus x naught, and this is called 1-point form. Yes, so if I move everything a little bit to the left, and this is 1-point form. Yes, okay, but this is a little bit different. So this is not that different from here, because, for example, if I want to get this equation back from algebraic point of view, I can, for example, choose k equal to 0 here and choose m equal to b here. Then what happens? This equation reduces to this equation. So I would say that I don't need to separate these two, because this can be obtained from this by putting k equal to 0 and m equal to b. But this line is a little bit different. There is no choices for k or m, so that this will give me this equation. Yes, because in this equation there is no y. If I want to get rid of y should have a coefficient, so that I can choose that coefficient equal to 0 in order to get rid of y. But the coefficient of y in this equation is 1, so it means that there are no choices for k and m that gives me this equation. So if you say that I have a line and its equation is this is not 100% correct, because this does not represent all possible lines. It represents all possible lines except vertical lines. So what I want to say is this: if L is a straight line, and if L is not a vertical line, then an equation for L can be written as y equals to kx plus m. Yes? So most of the time the equation of lines are of this form, except the vertical lines. If I have a vertical line, I cannot get this from this equation. Is that understandable?
No, explain once more, please.
So what I'm saying is that, for example, if I ask you, assume that you have an equation y equals to 3. Okay, can you tell me what choices for k and m will reduce this equation to this equation? It is simple. I would say that, okay, in this equation there is no x value, so it means that what I choose for k is equal to 0, and what I choose for m is equal to 3. If I replace k with 0 and m with 3, this equation turns into this equation. Yeah, is it clear? If I put k equal to 0, this is gone.
Yeah.
Okay, so it means that if I change my mind and I write y plus 5 equals to 0, then again you would say that, okay, I can choose k equal to 0 and m equal to minus 5. Yes, why? Because if I put k equal to 0, this is gone and this becomes minus 5, so y equals to minus 5 is exactly this one. If I ask you what do you think about this equation, so y equals to 5 minus 3x, I would say that here I choose k to be minus 3 and m to be 5. Yes? But if I ask you the same question for a vertical line, so do you remember an equation for a vertical line is something like this. If I ask you 5 and I ask you, can you choose some values for k and m so that this equation gives rise to this equation? The answer is no, it's not possible, because what can I do? If I want to have this equation, somehow I need to get rid of y, but choosing k and m doesn't have any effect on y. Yes, so by any choices of k and m I cannot get rid of y. So it means that this equation cannot be reduced to an equation of this form. So it means that if I have a vertical line, these vertical lines are different classes of lines that you cannot find the equations of them using this formula. Now is that clear?
Okay.
Okay. So the question is that, so I'm just telling you, can you just choose k and m so that this equation becomes this equation? Can you do that?
I guess no.
So that's it. Might be I made it complicated, but what I'm saying is that for this type of lines, you can choose k and m so that after plugging those numbers here, this equation turns into your equation. But if I give you this type of equations, vertical lines, then it doesn't matter how much you spend time, you will not be able to find k and m so that this reduces to this in this way. That's my point.
Okay.
So then it means that let us somehow get, so this is most of the time good, but we need a more general equation that it is not only capable of producing all these sorts of lines, but it is also possible to produce this line using that equation. And that is the general form. So I would write the general form, general equation of a line. Okay, and what is a general form? I would write it like this. This is a general equation. I would write ax plus by plus c. If you ask me what are a, b, and c, I would say a, b, and c are real numbers. You remember this symbol means belongs to, and this is the set of real numbers. And a and b are not simultaneously 0. A and b are not simultaneously equal to 0. Now I am this is not an equation. You need to immediately complain. Equation means equality. Okay, so this I want to talk about this equation a little bit today, and then start solving a diversity of problems so that you can improve your skills. I am claiming that if you have an equation of this form, if you choose whatever you like for A and B and C, with only one restriction, you are not allowed to choose 0 simultaneously for A and B, then this equation is an equation for a straight line. Let us investigate this a little bit more. One scenario is that, for example, A is equal to 0, but B is not equal to 0. Let us investigate to see what happens in this case. If A is equal to 0, this is gone. Then what I get is by plus c equals to 0. Then what happens? This gives me y, by equals to minus c. Because now I am assuming that b is not 0, I can divide both sides by b. Now I ask you, do you agree that this is an equation of a line? If you agree, what type of line is this?
I think a straight line.
Yes, but what type of straight line?
Horizontal.
Horizontal, yes. So that's a horizontal line. So you see that in this equation, if I choose A equal to 0, but B not equal to 0, this equation reduces to an equation for a horizontal line. Now let us consider another scenario. This time let me consider that A is not equal to 0 and B is equal to 0. Let us investigate the consequences of this assumption. So in this case, B is 0, so this is gone. So I will have AX plus C equals to 0. I move C to the right, so it becomes AX equals to minus C. I divide both sides by A. I am allowed to do that because I have assumed that A is not equal to 0. Then I will get this one. Now, do you agree this is also an equation for a line? Yes, but what type of line is this?
Perhaps it's vertical.
Yeah, not perhaps, definitely it's a vertical line. So you see that this drawback in this equation is not, it does not appear here. This equation was not capable of giving me this vertical line. But this equation is capable of giving those lines. For example, if I want to get this back, what choices I can make? I can make A equal to 1 times x. I can choose B equal to 0 times y. And I can choose C to be minus 5 equals to 0. So you see what happens. This will go away. This becomes x minus 5 equals to 0. But this means x is equal to 5. So we saw that the previous equation was not capable of giving me this. But if I work with this form of equation for particular choices of A, B, and C, in this case A equal to 1, B equal to 0, and C equal to minus 5, I was able to reduce this equation to that equation. So that drawback, I don't know, that flaw, deficiency, which was in the previous equation, does not appear here. And then what happens if neither of them is equal to 0? A is not equal to 0 and B is not equal to 0. I hope that still you agree with me that it is still a straight line. Why is that? Because what I can do, I can move AX and C to the right, then it becomes BA is equal to minus AX and minus C. Because B is not equal to 0, I am safe by dividing both sides by b. There are two terms to divide on the right hand side, so it becomes minus a over bx minus c over b. Now let me write this equation so that below it, that equation was kx plus m. Now you see, is it comparable? Is the form of this comparable to the form of this? I would say yes, if I choose k value to be minus a over b and the m value to be minus c over b. So you see that there are three possible cases in general that can happen. In each one of these cases, this equation reduces to an equation that I already know is an equation for the straight line. So I would say that this is always representing a straight line. Of course, the only limitation is that a and b cannot simultaneously be equal to 0. Okay, now let me ask you one more question. If I ask you what is the slope of this line, what is the answer?
K.
It's k. Now if I ask you what is the slope of this line, you would say that I cannot immediately answer that. I need to follow these steps, and when I write it in this form, I can now answer. Can you tell me what is the slope of this line by comparing it with this general form?
Minus A over B.
Minus a over b. Yes? So hopefully now you see that this is the general form. It is not only, so the previous one was not all the possible lines. They are all possible lines except vertical lines. So if I use this equation all the time, I need to be worried about that this is not considering all equations, all lines. It is considering all lines except vertical lines. So if something is in back of my head, always you need to be worried about this exception. So when you say that I have a line, you cannot immediately say that the equation of that line is of this form, because you might be unfortunate and that line is a vertical line, and that line, if that line is a vertical line, you cannot write it in that way. But if I say that I am dealing with a line, its equation is of this form, then I am on the safe side, because even if my line is a vertical line, this equation is capable of producing it for me. You see, it produces a vertical line if necessary. So this is called the general formula, the general equation of a line. So let me correct this. There is an of here. Of a line, yes. By line I always mean a straight line in this lesson. Okay, so this hopefully, but I don't know, is GeoGebra capable of drawing the graph of a line like this? Let us test that. So for example here, let me see if I write x plus y, because usually you need to put y on the left hand side and equal to this. But let us see, x plus y equals to 1. Yeah, GeoGebra actually understands that. So this, you see, this is exactly the straight line. So let me move it inside here to have a little bit bigger space. Okay, so you see that it was also GeoGebra knows that this is equation of a line. So, and this is the line that the GeoGebra was sketching it. And of course it is also understandable for you, because if you see here, if I go back here, I wrote x plus y equals to 1 in GeoGebra. Now let us compare this with this equation. Okay, now can you tell me what is playing the role of A in this equation, what is playing the role of B, and what is playing the role of C?
I think that A and B are 1 and C is 0.
No, C is not 0.
Okay, well, C is negative 1. Actually.
Yeah, C is negative 1.
But are there supposed to be two x's?
Ah, yes, yes, thank you very much. Thank you very much. No, that was my mistake. Thank you. This is y. Yes, now if you compare, so these numbers are correct. A equals to 1, B equals to 1, and C is equal to minus 1. If I ask you what is the slope of this line, if you want to answer this question, of course in that case, you write it in this form, and then you answer. If in this equation, so let me write it in this way. So if I ask you what is the slope of this, you would say that I keep y here and move x to the right, it becomes negative x, or if you want to, you can write it in this form, minus x plus 1. Okay, now can you read k value here?
It's 1.
No, no.
Minus 1.
Minus 1. K is -1. So the slope of this line is -1. And it is clear, by the way, do you remember I told you this is inclined in this direction. Every line in this direction should have a negative slope, because when x increases, you see the y value decreases. So the slope should be negative here. Okay, so now hopefully you understand. So this is not something very serious or very strange. If you want to consider all possible lines in one equation, then you need to follow this equation. This is called the general equation of a line. Okay. So let me just repeat it. If you say that I have one equation, so if I ask you write an equation for a line with some properties, if you say that, okay, let me assume that the equation of this line is of this form. If you are lucky and your answer is not a vertical line, you will find it. But if you are unlucky and the answer to the problem is a vertical line, by assuming that the equation of your line is of this form, you will not be able to find it, because this equation is not capable of generating vertical lines. That's what I'm saying. But because of course, most of the time, the answer to the problem is an inclined line. Of course, you are on the safe side if you use it, but I want you to understand, by considering this, you are not considering the most general case. You are excluding vertical lines by assuming that this is the equation of your line. And if you remember, when I wanted to find this formula, which gives rise to this formula, I was assuming that this line is inclined. Yes, if you go and see the proof, remember it again, you will see that this was based on this assumption that the line is an inclined line. Okay, so hopefully you understand everything. But for example, let me write something here. xy equals to 1. Do you think that this is representing a straight line, this equation?
Yeah.
The answer is no.
Okay.
Why? Because every equation, if it is going to be a straight line, it should be able to write it in this form. And you see that it is not possible. The only degree of freedom that you have is to playing around with these numbers. But it doesn't matter how I choose these numbers a and b. I will never ever get a term like x times y. It doesn't matter, you see they are separated by this addition here. If I start playing around with these numbers, there is no chance for me to come up with a pair of numbers which generates this product for me. So this means that it is not possible to write this equation in that form. If it is not possible, then it means that this is not a straight line. Okay, let us check this one by GeoGebra. For example, let us get rid of that. And I don't know if GeoGebra is capable. Might be it will complain. Yes, it complained, you see. GeoGebra, yeah. So for the straight line, it didn't complain that y is on the left-hand side. So actually, it doesn't do anything. No, this is...
That's why you use Desmos, because it works there.
Does it work?
Yes, I tried it. It works there. It's really weird. It gives like two different lines.
Yeah, that they are not two different lines. They are two different curves. You mean if I put 1.1, you mean? No, I don't understand what you say. How did you say?
I put it on Desmos.
What do you...
So x times y is equal to 1.
Oh, okay, x times y.
Yeah, that's what you... No, I put it in... it's a different app.
It's a different app, yes.
Yes,
okay,
all right,
yeah. Okay, I understand. It's called Decimal. The name of the app is Decimal. But anyway, it's not hard for us to use GeoGebra somehow, because if I want to do it, it should be a way that I can, I don't know if there is in GeoGebra, is there any, because this kind of graphing is called implicit curve. You see, if I use this implicit curve, I don't know then what will happen here. No, this is list of points. No, I don't like it. But I want to have implicit curve. Implicit curve this function. Okay, now let us use GeoGebra to see what it works. Then it becomes xy. Let me see. Might be I have to put -1. Yes, now it works. You see, so there are some tools. Implicit curve. This is, I remember this should be this instruction. So you see now, if I want to do, oh, this was not a good way to do. I don't know why this goes this way all the time. Okay, so here you see in GeoGebra we did this, and you see that this is not a straight line. The curve consists of two parts. Okay, but still, but this is not a straight line. Okay. So it is important to realize what is you need to learn in this lesson is to see that whenever you want to have a straight line, this equation should be able, you should be able to write your equation in this form for some choices of A, B, and C. If there are no choices for A and B and C, so that it gives rise to this equation that you are considering, you are sure about one point. The point is that the curve is not a straight line. The graph is not a straight line. This you need to understand. Anyway, is that clear now?
Yes.
Okay, so this is also for the Math 2C lesson. This is also important to know, and that is called the general formula or general equation for a straight line. The only constraint that you have, you are not allowed to put A and B simultaneously equal to 0. And of course that's clear, because if you put A and B simultaneously equal to 0, then you will get this one. But this is not an equation of set of points, because set of points should at least have an x coordinate and y coordinate in it, but there is nothing here. Okay, so this is it. Let me see, are there other things that we can talk? And then, so what is important? So if I ask you what is the slope of this line, y minus 5, what is the slope of this line? What is the slope of this line? What are the slopes of these lines? What is your answer for the first one? What is the slope of this? You should be able to do it and answer immediately.
1?
No, the slope of this is 0. Why is that? Because, first of all, there are two reasons. There is no x here. When in your equation of the line there is no x, it means that your line is horizontal. If there is no y, it means it is vertical. If I have a horizontal line, so the slope is 0. If I have a vertical line, the slope is undefined. So be careful about these points. If in an equation of a line there is no x's, it means that you have a horizontal line. And if you have a horizontal line, the slope is 0. If in your equation of the line, of course, not in any equation, because if this is, I don't know, if I have y squared minus 5 equal to 0, this is not a line in the first place, because I have a power of 2. You see, in the line equation, I have just 1x, 1y with powers 1. Okay, so if you have an equation, which is an equation of the line, and there is no x, it means that your line is horizontal, and then k value is 0. In the other case that there is no y, it means that your line is vertical, and therefore k is not defined. And in other cases, you need to write it in this k form and read the x coordinate. And this is very important to remember. When you want to write it as the k form, this has to be equal to 1. If it is not, first divide it by that number so that it becomes 1, then start reading these coefficients. And by the way, you see that if, for example, let us go to GeoGebra. I don't know if I can do it here or not. I have some ideas, but I don't work with that much. So for example, let me make a slider here. I will call it, let me call it K for K value. And then you see, let us make it from negative, I don't know, negative 2 is enough, up to 2. This is the range of your slider. And then you can increase it. For example, I can say that I want to increase it 0.1 each time. It's good. So let us just write it here. And then let me see if it works or not. And then I write an equation for the line. For example, K is exactly this slider that I introduced here. And I would write it Kx and then plus, for example, 2. Okay? Why this is this graph? Because K value is now on 1, so it means that GeoGebra chooses 1 for K, and then it becomes x plus 2. But of course, if I ask you what is the slope of this line, you would answer it is K. In this case, K is 1, so the slope is 1. But let me start changing K. What do you think will happen if I just start moving K around here? What is your prediction? Does the line, definitely line will start changing, but do you think it will translate itself up or down, left or right, or it would be go rotational?
Rotational.
Yeah, it should be rotational, definitely, because K value is the angle. Do you remember yesterday we learned? K value is the angle that this line makes with the horizontal x-axis. When I am changing K, it means that I am playing around with this angle. So if I change this angle, make it bigger or smaller, so this definitely will make the line start rotating in a weird probably way. Yeah, that would be a little bit harder to understand the behavior if you don't know higher mathematics, but just you understand. Let us just move it, you see? So this is moving around that point. Of course, that was also simple to predict. Could you predict that it will rotate around that point?
Yes, because you added 2, perhaps.
Yes, because that number is called the y-intercept. What is the y-intercept? Let me go to this notes here. If I have y equals to kx plus m, if I put x equal to 0, I will get y equals to m. So this means that the point with coordinates 0 and m is definitely on the line. Okay? So x is 0, y is m. If m is positive, for example, I will get a point here. This would be a point on this line. And this point is called the y-intercept. Okay, if m is positive, the intersection of the line with the y-axis is above the x-axis. If m is negative, I will get something below. If I go to GeoGebra back, you see I am not changing this 2. For all these lines, this number is fixed. What I am changing is this number. So it means that all those lines has to pass through this point, because the y-intercept of all these points is exactly this point. So this point should remain fixed on the one hand. On the other hand, you realize that this line should start rotating. So if you put these two arguments, two sentences next to each other, you immediately conclude that this point would be the rotation, the center of rotation of the line. So you see that. Okay, by the way, there is a good exercise. Do you think that I can make this K bigger so that this becomes vertical? Because it seems, you see, let me start with 0. This is horizontal. Could you predict that? When k is equal to 0,
Yes.
it means that, yes, it means that the k value is 0, so that's a horizontal line. I start increasing k, you see that this is getting closer and closer to vertical direction. Okay, and then unfortunately up to 2 I stop. But what is your prediction? Can I increase this interval to bigger numbers so that I make this line vertical at some point?
So
Yes.
you could probably do that, but I don't think you'd ever get to like fully vertical.
Exactly.
But you could get really close. But
That is the
never
best answer
truly
that I
vertical.
wanted to hear. Yes. Yeah, that is the best answer. Why? Because if, let us check, by the way, I don't know, can I change this a little bit? I am changing now. So let me make the maximum 10. So let us see what happens now. Oops, this is another one. Why this is another one? Okay, so
press on the settings tab.
yeah, let me get rid of A. Okay, but now you see the maximum value for K is 2. Let us go further and further. You see, this is not happening. The angular velocity, the rotation velocity is actually getting smaller and smaller. You can see all of these things later in physics courses and everything, but of course everything is mathematically clear. So, but let me increase it a little bit here. So I don't know. Can I do something here? What you said, setting here? There should be a simpler way to change the fine. Okay. I don't know. I just randomly clicked. What happened? So let me make it 100 to do some game. Yes. So here, let me start from 0, as usual. Yeah, close to 0. So this is 0, and now I start rotating it. Okay, so I will go. You see, it's getting closer and closer. You see, but it's not never vertical. You understand that?
Yeah.
Yeah. So this is a nice way to see that if you write an equation of this form, you can get close to vertical lines, but vertical lines are excluded. It doesn't matter how. Of course, if I change it to 1000, I don't know, might be our eyes cannot recognize the difference, differentiate between these two. Let me check if that's working. So you see, now our eyes cannot recognize, but from, I don't know, is there any way that we can see? No, might be no. So you see, it's so perfect that we cannot see the differences of the vertical line. But if you know mathematics, you should know this point, that it doesn't matter how I make this big, it will never be a vertical line. Okay? Yeah, even for those ranges, I cannot see the difference. Yes. Up to, I don't know, up to 100 something, 200 still I can see the difference, but above that I cannot see the difference. But I want you to understand, definitely that's not a straight, that's not a vertical line, because there is a slope for it. Vertical lines, the slope of vertical lines are not defined. And then let me also check this idea, so let us get rid of these. Let me write an equation of this type. Let me fix the slope, write y equals to 2x, but let me write this time plus m. It should create, okay, so it created automatically. Now what is happening? The y-intercept, you see, let me make it a little bit bigger. So this y-intercept is what? Is 1 in this case. Okay. But so how should I make it? Okay, now it is 1. It is clear. Now what happens, do you think, if I start sliding this slider back and forth? What will happen, do you think?
It will rotate around the 1.
No.
No.
Rotation is not good. Yeah. Pardon?
It will move up and down.
It will move up and down, yes, because I told you,
Right.
I told you that this number is the y-intercept. This, let me make this point clear for you here. This point that you see here, this point is now at 1. When I increase m to a higher value 2, then it means that the y-intercept should be 2. If I increase it more to 3, then it means that the y-intercept should be this one. So it means that this point start moving up if I increase it. If I decrease it, it means that this point start going down. So let us check that. You see, it's going up. And if I go to the negative at 0, it is exactly passing 0. And then for values like that, it goes down. Of course, your eyes might say that this is also going to the right or left. That's more or less, if that is the case, that's also correct, but you are looking it from the x direction point of view. So, that is, so if you want, by the way, this you will see later. If I am increasing m, with respect to y, the line is going up with respect to y. But with respect to x, it is acting weird. It is going to the left. And when I decrease it, with respect to the y, it acts normally. It goes down. But with respect to x, it acts a little bit weird. It goes to the right. But don't worry about the x direction for the time being, for the y direction. So hopefully you understand what is the effect of changing m and changing k. Changing m will shift the line up and down. Changing k will start rotating the line around the point of y-intercept. Okay, is that clear?
Yes.
Yeah.
Okay, now let us go to solve some analytic problems. These are the exam type of problems, so you need to know. Okay, so let us start with very simple ones. Number 1, sketch the shape that is represented by the given equation. This is what I want you to fully understand. Just by looking at each one of these equations in less than 2 seconds, I expect you to understand that you are looking to an equation for a straight line. This I want you to immediately understand. So is that understandable for everyone? Is that understandable that this is an equation of a line? This is an equation of a line, this is an equation of a line, this is an equation of a line.
Yeah.
Yes? Okay.
Yeah.
This you need to train your eyes for that, because immediately you should compare this with the general form. Okay, and if I want to sketch the graph, I think this is very simple, so let us just, you can help me to do that. What is the sketch of this graph? It is a line. What type of line is that?
Vertical.
It's vertical, passing through
-3.
minus 3, yes, exactly. So let me just do it very quickly. You don't need, so 1, -2, -3. So if you want to sketch that graph, this would be a sketching of that line. Yes, so this is x equal to -3, and of course this is the x-axis and this is the y-axis. For number 2, what is number 2 then? What type of line is that? It's a horizontal line, yes. So, but how should I understand, how should I draw it? I would solve it a little bit. So I would say 2y minus 4 equals to 0, so y is equal to 2. So it means that my line is a horizontal line passing through the point y equals to 2. Yeah? So that is y equals to 2 if this point is 2. Here this point is 3. Minus 3, sorry. Okay, but what happens if I want to sketch the graph of this? What is your suggestion? Because this is neither a horizontal one nor a vertical one.
So doesn't this follow this kx plus m pattern? So we know it's like has some sort of angle. I don't know how to say it. So plus 4, we know it would like intersect the y-axis at 4.
Yes.
And with since k is negative, we know it would be like going down. I don't know how to
yes,
say.
yes. Now you are on the right track, but this is not very practical. You can, of course, you can use it. Let me use your idea. I think now it is working. When I think a little bit more closely. So what you are saying is this. You are saying that by looking at this equation, and if you have trained your eyes, you immediately detect a pattern, and you see that this is the k form of an equation, and this is the k value, and this is the y-intercept. So finding the y-intercept is easy. It is positive 4, so I go 4 units, 1, 2, 3, and 4. So this would be my point. But I know that my slope should be negative 2. So it means that if I go 1 unit to the right, how much I will drop? Because why I say I drop, because k value is negative. So it means by going to the right, the y value should decrease. So it means that I am dropping. But 1 unit to the right, how much I drop in the vertical direction? 2, exactly. So it means that you can do it like this. You can say that I go 1 unit to the right, but it gives me a drop of 2 units. Yes? So this means that this should be my point again. And then I connect these two together. That would be my line. Okay, so that's not a good picture. So this is one way. By the way, I didn't think about doing it in this way, but that is also completely correct. Is that understandable for everyone?
Yeah.
Okay, so
It should intercept the 2 at the x-axis. Is that correct?
yes.
Okay.
Yeah. So, but this is why I even though this is completely okay, at least it is very good from understanding the concept. But I would prefer to find 2 points of my line and then connect them. Okay, so if I wanted to do this, I will set up a table. For example, I would say here, I will set up a table of 2 values for x and 2 values for y. One thing is very good. I put x equal to 0, and then I calculate y using the equation. If I put x equal to 0, y becomes 4. So what does this mean? It means that the point 0 and 4 is on my line. But of course it was completely predictable because that's the y-intercept. But another time I put y equal to 0 and try to find x. How can I do that? When I put y equal to 0, I will face this equation. Then it means that 2x is equal to 4, so it means that x is equal to 2. So I put 2 here. Then instead of doing it in this way, I will do it in this way. Okay, so what I do, so I don't know where to draw it. So let me draw it with a different color on the same axis. Okay, so here, what I do, I will go and find this point and this point. This point is already found, so that is common with your method. And then now I find this point, as you pointed out, this is also this point. Now I connect these 2 pink points together, but of course I definitely will get the same line. This is not surprising, but usually this is the standard way of sketching the line. Putting x equal to 0 and find y, put y equal to 0, find x if they are different, and then connect those 2 points together. The reason that I want to do it, because usually it is important for us where this line cuts the x and y axes, okay? But sometimes it is not possible to do that. For example, if I ask you to sketch the graph of this function, y equals to x, then if you want to set up a table, if you put x equal to 0, of course you get y equal to 0. But if you want to put y equal to 0, you again get x equal to 0. So that is not a good information because that's the same. I need 2 pieces of information. So here I choose another value for x, say 1, and then I get 1 for y. And if I want to sketch that, it's easy. 0 and 0 is this point, 1 and 1 is this point, and then I connect these 2 points. And of course, this will continue forever from both directions. Okay, so This is a good way of doing that. So let us just do this for number 4. So number 4, first of all, hopefully you immediately realize that this equation definitely is a straight line that has the general form ax plus by plus c equals to 0. A value is 2, b value is minus 3, and c value is minus 6. But if I want to sketch this graph, I would do this again. So I will set up a table. Yes, it doesn't matter if it is vertical or horizontal, whatever you like to. So first I put x equal to 0. Once more I put y equal to 0 and try to find these question marks. So what is this one and what is this one? What is the first question? It's very simple. I put x equal to 0. So this gives me 2 times 0. Sorry, this is not a good way of writing. 2 times 0 minus 3y minus 6 is equal to 0. This is completely gone. Minus 3y is equal to positive 6. So y is negative 2. So what I need to put for this question mark is negative 2. Okay? And now here I put y equal to 0 in the same equation. So then what happens? It becomes 2x minus 3 times 0 minus 6 is equal to 0. So it means 2x is equal to 6. X is equal to 3. So this question mark is now 3. And then I will go and find them on the x and y axes. By the way, this is also good to know. This point is, you know that this is called y-intercept. This point is called the x-intercept. Okay, so 0 and minus 2 is here. So my y-intercept is here. This point, if I call it point A, if I call it point B, this is my point A. And the other point is 3 and 0. So this is my 3 and 0. This is point B. So let me write B on the left hand side. Okay, now if I ask you what is the graph, you connect these two together. So it becomes this. Yes, so this is the line. Of course, you need to continue from both sides. Yes. So that's the sketch of the graph. So I would recommend you, what Rocco said is actually completely correct. It's very good to understand it in this way. But when you want to draw the graph, if it is vertical, just draw it. You need to recognize it's a vertical one, just draw it. And if it's horizontal, recognize that and just draw it. But for other inclined ones, let us just use this method. Okay, so let us go to the next question. Okay, so let me answer, you can answer this question. Determine the slope, if defined, of the lines whose equations were given in the previous example. Okay, just let us do it together. What is number 1?
Undefined.
Undefined, exactly. So undefined, it's vertical. And number 2,
0.
k equals to 0, thank you. Number 3,
minus 2.
yeah, k is equal to minus 2. And finally, number 4. If this is given in the exam, number 4, don't answer it immediately, because you need to show me that you know how to calculate. What can I do? Can you tell me? I want to find the slope for this line, which is given in the general form. What should I do first?
Minus A divided by B.
Yes, but just don't give the answer immediately. What should I do? You need to show that you are doing the correct way. So it means that you want to make y alone, yes? So you move 2x to the right, you move minus 6 to the right, and then you divide by minus 3, because I want to make y alone. So then it becomes minus 2 divided by minus 3x plus 6 divided by minus 3. Then y is equal to 2/3 x minus 2. This is the k form. Now can you tell me what is the k value? 2 over 3. So this is mandatory, so just do it in the exam. If this is horizontal or undefined, just say it. If it is already in the k form, you just read the k value. But if it is not in the k form, it is in the general form, you need to write this down, make it into the k form, and then read the k value. What is the y-intercept? What is the y-intercept here?
-2.
Alright, by the way, -2 is not the correct answer. Might be I was a little bit sloppy. When I say y-intercept and x-intercept, I mean points. When I say points, you have to give me two numbers, x-coordinate and y-coordinate. So when I ask you what is the y-intercept of this line, you shouldn't say -2. You should say the point 0 and -2. Yes, exactly.
Okay.
Okay, so this is something that we practice. Now let us go to number 3. This is also a simple exercise, but it's crucially important. Okay, so which one of the points A and B, if any, does lie on this line? How can I answer this question? Of course, I can draw the graph of this using GeoGebra and locate these points using GeoGebra, and I can see it by my eyes, even though it is not a very good method. Why? Because it might be off the line, but the distance between this point and that line might be so close that my eyes cannot detect them. So this is why it's important. By just looking is not good, because if the distance is so close, I cannot differentiate it. But analytically, I can be 100% sure is it on the line or not. But can you tell me the strategy? If you see this question, how you can answer this question analytically?
Continue 14 to the other side. And then put in the points -2 to x and 4 to y. And then if it gets 0, then it's on the line.
Yes, okay, but exactly, but you don't need to move anything around. If you do it, it is not wrong, but it is unnecessary to move something around. So what I do, I would write 5x plus 6y. You want to make it like a function, but you don't need to do that. So what I do, I replace x with x, I replace y with y. If the equality turns out to be correct, then I would say this point lies on this line. If it is wrong, then it does not lie. So let us check. For the point A, -2 and 4. So what I do, instead of x, I put -2. Instead of y, I put 4. And then ask myself, is it equal to 14 or not? So let us calculate. What is the left-hand side? -10 plus 24. Is it equal to 14? This becomes 14 equals to 14. So this is true. So this means that A lies on the line. Is that understandable?
Yes.
Okay, so let us check the other one. 2 and -4. I put 5 times 2 plus 6 times -4 and ask myself, is it equal to 14? You say 10 minus 24 is equal to 14. It tells you that -14 is equal to 14, which of course is false. When it is false, it means that B does not lie on the line. Okay, so simple as that. So remember, when you want to check a point is on the line or not, you can just put the coordinates of the points inside the equation. Okay, a little bit higher level questions would be, these are not hard of course, none of them, but let us for example consider this. Consider the line this. First of all, hopefully you don't freak out by looking at this. Do you remember that this, I want you to be able to immediately see that this is an equation of a line. If you compare this with this scenario, so let me just write it for you. By ax plus by plus c equals to 0. Here, a minus 2 is playing the role of this a, minus 3 is playing the role of this b, and if I move this to the left hand side, becomes minus 2a plus 4, this will play the role of this c. So it should be a matter of seconds to recognize that this equation is an equation for a straight line. Now this question is asking, determine a, this unknown value a, such that this line passes through this point. So what is the strategy to solve this problem? Mm-hmm.
And a minus 4 on the other side. And then solve it like
so solve for a, yes, that's correct. So what you are saying is that because this line, this is a line, don't make it complicated. Who cares about algebra? From algebraic point of view, sometimes the equations are a little bit hard, but from geometric point of view, who cares? That's just a straight line. Who freak out from a straight line? No one. That's a straight line. And this is a point. Who cares? This is just my point A. I want to make this line passes through this point.
Hello.
Yes?
Can't we just solve the right side for a equals minus 2 instead of mixing with the left side? Wouldn't it be easier?
Yes, I don't want to move things around.
I was just wondering if it's a viable option.
No, right now I don't want to do something like that. So I want you to understand, first, because I don't understand what is your strategy. I want to say that this problem is exactly as the previous problem. In the previous problem, a point was given to me. I wanted to check if it is on the line or not. Here, I want to fine-tune this so that it passes through this point. Okay? So it means that the coordinates of this point should satisfy the equation. You don't need to move something around first. I don't know why you are interested to move things around.
No, I meant that you're right.
Okay. So that
minus 4.
Okay, so what I do, I would say that if I want to write it in the correct way, I would say that a minus 1 minus 2 is supposed to be on the line. Yes, this is the meaning when you say that my line is going to pass through this point. This English sentence can be written in a slightly different way, saying that this point is supposed to be on this line. Yes, I hope that you understand these are equivalent. Then this implies that if I replace x, I am not allowed to touch a. If I replace x with the x value and replace y with the y value, this becomes equal to 2a minus 4. This means that this should be a true equality. This then means that find a such that this is a true equality. But this means solve the equation. Yes, this is an equation in terms of a now. So I want to solve this equation. So I multiply this inside minus a plus 2 plus 6, and on the right hand side I have 2a minus 4. And then you know how to solve this, yes? Minus a minus 2a, and then I will write minus 4 minus 2 minus 6. I am moving things around. Here I have to move things around. You see, from the beginning, why I should move things around? Because I don't know what's happening. My strategy, I need to have a strategy to solve my problem. Why I start? It is not hard, of course, if you things move around, but it's not time consuming very much in this simple problem. But the problem is that why do I want to do this? Here, I am using this strategy, and I came up with this idea that I want to find A so that this becomes true. Then I remember my previous lesson that I want to solve an equation of first degree, then I have to move things around. This is very important. If you want to learn mathematics, you need to follow some strategy. Here, I definitely agree with you to move things around. Okay, so then the left-hand side becomes minus 3a, the right-hand side becomes minus 12. Then I am looking for a, so a becomes 4, yes? So it means that, by the way, it's a good idea if we use GeoGebra to see what is the meaning of this problem. Hopefully, I don't know if GeoGebra is capable of doing this. So let me write down this, not to go back and forth. So this equation is a minus 2 times x minus 3y is equal to 2a minus 4, and the point is minus 1 and minus 2. Let us see what does it mean, what we have done. And remember, we got a equals to 4. Okay, so let me get rid of everything here. Hopefully GeoGebra can do this, I don't know. So the equation was a minus 2 times x, and then I have minus 3y equals to 2a minus 4. Yes? Okay, good. And then let me also highlight that point. The point was a equals to minus 1 and minus 2. Yes, so this is my point. So you see, everything is clear. This is your point here. Let me make it a little bit bigger so that you can also see it properly. So this is your point, minus 1 and minus 2. And then I have I made a mistake here in typing, yes? No, it's correct, a minus 2. Okay, so that's correct. This is my equation of those lines. If I start moving this a around, it becomes a little bit complicated, because not only, you see, the x value, so it means that not only the k value, the slope is changing, but also the y-intercept is changing. But who cares? This can be done by GeoGebra for us. But let us just move things around a little bit so that what happens if this is moving, you see? Yeah, okay, so it is also not very complicated, because now the x-intercept is fixed. You can check yourself that the x-intercept of all these lines is equal to that point. Okay, but now let us see. This tells you that, you see, I am changing this. This line is rotating, but it is not passing through this. As if our calculation is correct, when a value becomes exactly equal to 4, then this line definitely should pass through this point. Let us check it if this is correct. You see, a is minus 0.9, I am changing it. If I have done my calculation right, when a becomes 4, this will happen. It's not happening yet, but now 4, yes. And exactly, it is confirmed. You see, when a is equal to 4, then that line is passing through this point. So if I ask you, is this an equation for one line? You would say no, because by giving different values for this a, I will have different lines. So I have infinitely many choices for a, so it means that I am facing infinitely many lines. Among all those infinitely many lines, I want to choose that particular line that passes through this point. I didn't do anything, I just simply calculated it, and I confirmed this calculation simply by GeoGebra. Is that understandable for everyone?
Yes, but your screen share has become a bit pixelated.
What?
At least for me, your screen share is very pixely. Oh, it fixed itself. Never mind.
Okay.
It looks fine on me.
Okay.
Fine for me.
So it might be that you are putting a lot of load on your computer. Yes, I don't know. Anyway, so this was a very nice way of understanding things. So you see, I was not just randomly, I calculated a equal to 4 and then we immediately confirmed that. But by the way, do you understand, it was strange for me, I didn't care about this point. You see, why, you see nothing, something is not changed on these points. What is that? This is this point. So it means, yes, the X-intercept is not changing. Can we also go back and confirm that by calculation? I was a little bit careless with saying that this would be strange. But what? How can I calculate the X-intercept? Tell me. So this is not part of the problem. So let me write it with a different color. So let us check X-intercept. Can you tell me what should I do for finding the X-intercept?
So for the X-intercept, you just set y to 0 and you solve for x.
Exactly. I have to put y equal to 0. Very good. So I put y equals to 0. Then what happens? It becomes a minus 2x. It was not easy to predict it before calculation. So 2a minus 4. Then let us see what nice thing happens here. So it becomes a minus 2 x equals to 2a minus 4. Yes. But what is x? X is equal to the right hand side divided by a minus 2. Okay? But now, can I simplify something here? Because it seems strange. You know, I was careless. I didn't see it until the end. Now I understand what's happening. I thought that x depends on a. But this is apparently depending on a. Can you see why? These things you should be very quick at. You need to do practice so that you can see it. Can I simplify something in this fraction? Our old lesson.
I think you can factorize.
Exactly. Exactly. So it becomes 2a minus 2 and the denominator is a minus 2. What do I get? 2 without depending on x, and that is exactly what was confirmed. What was confirmed for that calculation. Do you agree?
Yes.
Okay. But if you want to be very precise, this is something is wrong about this calculation. We can go back and probably confirm that with this one. If I ask you, do you believe that this is equal to 2 always?
Not always.
When this is the problematic?
If there's another a value.
No. This is most of the time 100% minus.
Oh, it's a vertical.
No. Look here. I'm asking, is this expression equal to 2? Of course, I have written it is equal to 2, and usually I don't make these kind of mistakes, but I told you something before, if you remember. This is not 100% true. This is true if the denominator is not equal to 0. Yes, if the denominator is equal to 0, then I am not allowed to simplify that. So in these kinds of things, you need to be very careful. I am simplifying it. Doesn't mean that I am doing something wrong, but implicitly I am assuming the denominator is not equal to 0. Otherwise, this doesn't make sense at all. So even
if a is 2, then it doesn't work.
So this means that if a is equal to 2, it doesn't work. Let us, by the way, go to GeoGebra to see what happens. Let us see. So, but it works here because can you see what happens if a is equal to 2? What I'm saying is that when you want to divide, this problem is correct if a is not equal to 2. It means that you have to consider a equal to 2 separately. This calculation is not capable of giving you what happens when a is equal to 2. This calculation is confirmed if a is not equal to 2. Okay? But let us now go see what happens if a is equal to 2. What happens? Can you tell me? Let me just write it here. If a is equal to 2, I will get 0x minus 3y. 3y is equal to 0. Yes, because 2 times 2 minus 4 is again 0. And then what happens? This gives me minus 3y equals to 0. This gives me y equals to 0. Okay, so this means that if a is not equal to 0, then the y-intercept is 2. If a is equal to 0, this is just this line. Can you tell me what is this line?
The y-axis.
That is, no, a small mistake. Y is equal to 0. It is the x-axis.
Okay.
Yes, it is the x-axis. Now let us go back to GeoGebra. Make a equal to 2. This line should be the x-axis. Let us see if it is correct or not. Try to see what happens when a becomes equal to 2. Our prediction is that when a becomes equal to 2, this becomes the x-axis. And that is your x-axis. You see, a little before that, and when it becomes 2, it's the x-axis. So you see, this GeoGebra or any other application is a very extremely useful tool when it comes to the connection between geometry and algebra. So you need to plan a lot of problems for yourself and try to understand what's going on. I will try to make this a little bit more interesting next time, but I will give you some homework. These are very simple ones. So I will upload the video, and then I also put a link for this one. So I would recommend you to solve these problems, which are very easy problems, of course. And then I will write which pages from the book you can also follow. Okay, so